We are in 1.3, which is about experimental design. So we are going to write the steps or guidelines for designing a statistical study. So the first one is to identify your variables. And the population. Step 2, develop a detailed plan for collecting the data and make sure your sample is representative of the population. So develop a detailed. The next part is you're going to actually collect the data. After you have your data, you're going to look at that data and describe it using descriptive techniques. So describe the data. So that could include finding the mean, median, mode, and range. It could be performing some kind of test on it, which we'll learn about more throughout the semester. And then you'll interpret that information. Interpret the data and make decisions about the population. And then the last thing is look for any possible errors or mistakes. So if the data doesn't make sense, that means you might have made a mistake at some point. So it's something important to look over. Okay, on this section, we have a lot of vocabulary. So observational study, whenever you just observe the data. You are not modifying anything. You are just looking at what's happening with that event. Experiment, you will actually apply some kind of treatment and proceed to observe its effects. So we could have a placebo group and a treatment group. And that way you can compare the difference between the outcomes on that. Simulation is a process that behaves the same way as the procedure itself, so that similar results are produced. You've seen teachers have used like random number generators, or I've used dice being thrown, but instead of doing it over and over and over again, I can use a computer program to do that for me. Another way we could use simulation is think about crash test dummies. Whenever you buy a new car, they tell you what the safety rating is. How do you think they know that safety rating? Are they intentionally putting someone in harm's way to get the information? No way. They got to have those crash test dummies. And they have to be the exact same size, weight, proportion, so that they're giving you the correct results. A survey. We have all done surveys where you're answering questions and then somebody's going to look at that question, those questions, answers, and coming up with some kind of inference about that. Ready to move on. Do you have this one on yours? Yes. Okay. The Pennsylvania Game Commission conducted a study to count the number of elk in Pennsylvania. They captured and released 636 elk, which included 350 adults, 125 calves, 110 branded, 51 spiked. Is this observational or experiments? So you got to think, are they just watching? Or did they apply some kind of treatment, placebo, and treatment to it? No. So what is it then? Yeah. Experimental design. There are three key elements of a well-designed experiment, which are control. So make sure you have these elements: control, randomization, and replication. So you'll hear the term control group. There needs to be randomization, not just selecting a certain few to get a certain outcome, and that the experiment can be replicated. Confounding variable. When we can see some effect but can't identify the specific factor that caused it. So think about it's more, there's an example that I think I talked about in Algebra 1, which talks about more drownings and number of ice cream cones sold. Those don't have a correlation, but there is a confounding variable. What would be the confounding variable? More drownings and ice cream cones sold. What do y'all think would be their connection there? Kids, summer, kids, and it being summer. Let's see. Placebo effect. Have y'all ever heard of that?
Yes.
Have you ever experienced it? Yes, maybe.
Probably.
Yeah. Blinding, when the subject does not know whether he or she receives a treatment or placebo. So that's important because they want to find out, is this really working or is it just that placebo effect? You take this medicine and you think it takes away your headache, but it's really just a sugar pill.
Oh.
Double blinding is when not just the patient, but also the doctor doesn't know if they're receiving or giving a treatment or placebo. Randomization, when there's a randomized selection of your different groups. I don't say, I decide who's getting the treatment, who's getting the placebo randomly. Completely, the randomness is used to assign subjects to the treatment and placebo group. A block, group of subjects that are similar but differ in a way that might affect the outcome. So think about the block of men and women. So their reaction to a certain experiment might be affected based on what their gender is. Randomized block design. Form blocks or groups of subjects with similar characteristics and then randomly assign treatments to the subjects within each block. Matched pair. Compare two treatment groups, treatment and placebo, by using subjects matched in pairs that are somehow related or have similar characteristics. So two examples would be a before and after and twins. So make sure to include those examples on matched pair. Before and after and twins. That's how you could do a matched pair. Replication. The replication of an experiment on more than one person. Good replication, I can't even say that word, it's a hard one, is done on a large sample. Let's look at this example. A high school studies class decides to run a mock election to determine whom high school students would choose as the next president. 38 students were polled as they walked through the door during a lunch, and the results are followed. Obama 21, Romney 15, Bart 1, some teacher 1. Identify concerns with the experiments and make ways to fix it to be more accurate and more representative. So this is called a certain kind of sample. It was just a convenience sample. So convenience samples aren't very good. So the flaw is that it's a convenience sample. So they didn't even survey all the students or even a good portion of them. So we'd really need to know what's the total population. And then we need to know if there's more than one lunch. So it says during a lunch. So it's a possibility that B lunch has a certain demographic. So you need to sample students from all lunches. And what about this whole Bart Simpson, you think, and the teacher? Do you think that's going to be helpful at all? No, they're probably just playing around. So what if you only get to pick from who's actually on the ballot? Only choose from a ballot. Okay, we have several more words. So you need to go through and read each one of these. And we just have one more example. Were there any you wanted me to show you?
Yes.
Okay, which one? Other page. Random sample?
Yeah.
When every member of a population has an equal chance of being selected. And you really want to use a random sample whenever you do this. Anything else? This page? Okay. You'll be able to go and watch the video. How about that? I'll post it. Okay, and then this page as well. And what you'll need to do is you'll need to answer these two as to what the sampling technique is. So you'll have to read through the questions and then decide on what sample it is, what kind of sample it is. You want to determine the opinions of students regarding stem cell research. Identify the sampling technique you're using when you select these samples. You select a class at random and question each student in the class. Select a class, so they're in a class, and then question each student. So this is going to be a cluster sample. So they're broken up into clusters or sections. Think about a class as a section. And then you randomly select some of those clusters. So select a class and choose all members from those selected clusters. So that is a cluster sample. You assign each student a number, and after choosing a starting number, question every 25th student. So that is the one that says select some starting point and then select every kth element. So this is called systematic.
Because they really care about the person.
That is it for chapter 1.